Practice problem number 2. We're still working with sample problem 3-3. Moving on to practice problem number 2. How many moles of gold, AU, are in, represent this nicely so you can definitely see it, 3.60 times 10 to the negative 10th grams of gold. Now, that's not a lot of gold, right? Can you guys tell that's a very, very small amount of gold? It's times 10 to the negative 10th grams. Very, very small. And so we're going to do a conversion here that's essentially the exact same as the conversion from practice problem number 1, but we're going to have to deal with some exponents here. Okay, so please follow my line of reasoning for how to do these, right? The reason I'm telling you this is because it works more often than any other mental procedure that I've come across, at least for me. All right. So we've been given 3.6 times 10 to the negative 10th grams of gold. Let's see. I'm going to erase that because I'll use that space.
Can you write it more up, please?
Hmm?
Can you write it more up? I can't see it on the wall.
Let's see. I'll use the space up. Let's see. I got to go. All right. I'll write it up here. So 3.60 times 10 to the negative 10th grams of gold. Set up my crosshairs here. I know I need to cancel out of grams, so I'll go ahead and just put that on the denominator immediately. And I'm converting into moles. So I'll put that on the numerator immediately. That way, when I actually do my calculation, grams will cancel out, they'll go away. And my final answer will be in moles of gold. So the question is, what do I use for the molar mass here? Well, look at the periodic table. And I see 196.96. Is that what I said? Mm-hmm. Nice. So, you ask the question, what number do I put in front of moles in my conversion factor? Whatever number you have in front of moles for your statement of equality. Same thing for grams. Whatever number I have in front of grams in my statement of equality. 196.96. And you can see the setup is telling me to multiply this value by 1 and then divide everything by 196.96. Now let's talk about what I'm going to do with that exponent. First step, I'm not going to do anything with the exponent. I'm going to ignore it for right now. I'm not going to do anything to it. I'm just going to do some math with the numbers out in front. Okay, so what I'm going to put into my calculator is 3.60 multiplied by 1 and then divided by 196.96. So I didn't do anything in my calculator with that times 10 to the negative 10. I didn't touch it. And so, the calculator is giving me a lot of digits here that I don't want to use. Okay, so I'm going to put that down as using 3 significant figures. That would be 3. But like, well, what about the times 10 to the negative 10? What do I do with that? And the reason I'm doing it this way, guys, is because I'm not going to tell you, I'm not going to show you how to do exponents in the calculator. First off, you're probably going to do it wrong. Second, everyone's calculator has a slightly different input for doing that. And so that means I'd have to do 200 unique calculator instructions. And that's just not useful. Also, it doesn't help you conceptually understand what's going on with the exponents themselves. And so I'm not going to attempt that. What I can tell you is, because I haven't done anything with this times 10 to the negative 10, that it's still here, right? It's still there. The question is, let's see, I'm not shiny, am I? Okay. Is this proper scientific notation? No. It's a correct value, but it's not in proper scientific notation, okay? Two things that are slightly different from one another. So in order to put this value into proper scientific notation, I'm clearly going to have to move the decimal 2 places. Okay, I think we're good there. So I'm going to end up with 1.82 times 10. Wait, I moved it 2 decimal places. So does that mean that it's now to the negative 8, or does that mean that it's to the negative 12th? Well, again, trying to memorize a bunch of rules works for some people, it doesn't work for some people. I want you to think conceptually. I'm not allowed to change the value here. Not allowed to change the value at all. I can change how I represent it, but the overall value has to be the same. So let me ask you, when I moved the decimal place here, did this number get bigger or smaller? Right? Is just this part bigger or smaller than this? It's bigger. Again, I'm not allowed to change the overall value. So in order to balance out the fact that this part of the number got bigger, that means that this part of the number has to get smaller in order to balance out that change. Okay, so I'm going to get smaller by 2 because I moved the decimal 2 places. Okay, smaller by 2. Well, what's 2 smaller than negative 12 or negative 10? Negative 12, right? Negative 12 is 2 smaller than negative 10.